Okay, here's another electrochemical cell in screencast 20.11. This is a little unusual in that we pump hydrogen gas in at 1 atmosphere into the anode, which is, again, on the left side, but it doesn't have to be on the left side, but it is here. And that will get oxidized down to H+, sending electrons flowing through this voltmeter across this copper cathode, where it hits the Cu2 solution and can reduce the Cu2 to copper, thus plating out copper at the cathode. Since this is generating pure copper from the copper sulfate, we need to pump in some cations here in the form of Cu2 across this salt bridge. Since this is generating H2 from H+, leaving chloride ions in here, we have to just pump in some Okay, in screencast 20.11, let's take a good look at another electrochemical cell. And this one's a little unusual in that at the anode we've got hydrogen gas being pumped in at 1 atmosphere. It gets oxidized to H+, sending electrons across this voltmeter, generating 0.34 volts, right through this copper cathode where it hits Cu2+, which gets reduced to copper, leaving sulfate ions all alone. And so Cu2 comes across this salt bridge to generate more copper sulfate. And don't forget we're plating out copper here. Since at the oxidation side the hydrogen is turned into H+, we have to also pump in Cl- across this chloride, across this salt bridge to regenerate HCl, and it generates 0.34 volts. Here is the oxidation half reaction, here is the reduction half reaction, here is the salt bridge. And there it is shown in a balanced half reaction. Here is the balanced reduction half reaction, and don't forget that overall we can see that what's happening is hydrogen and copper ions are being transformed into copper solid and hydrogen ions. So this is the balanced redox reaction. We can calculate the standard EMF for this from the cathode reduction minus the anode standard reduction potential. And here it is, the standard reduction potential by definition for hydrogen is 0, so we just have to look up this copper reduction, and in fact it is being reduced. That's what's happening at the cathode, and you'll see that it's equal to 0.34 volts. So 0.34 minus 0 equals 0. This is positive. The reaction should proceed in this forward direction. If it were negative, the reaction would be proceeding in the opposite direction, generating hydrogen gas, but it's not. And that is screencast 20.11.